Hi everyone, in today's lesson we're going to review optimization. This is another application of derivatives. So let's read the question first. A farmer wants to construct a rectangular pig pen using 500 feet of fencing. The pen will be built next to an existing stone wall, so only 3 sides of fencing is needed to be constructed to enclose the pen. What dimensions should the farmer use to construct the pen with the largest possible area? So if you remember when we did these problems way back when, we would always need a picture. Then we need a helper equation. And then we need an equation that we want to maximize or minimize. So in this picture, they're talking about a farmer wanting to construct a pig pen against a stone wall. So I'm going to draw my picture like this. So we'll say this is the wall. And here is my rectangular pen. So only these 3 sides here, this side, and this side will be needed. And they want to know what are the dimensions that the farmer could use to construct a pen with the largest possible area. So this part right here, when they're asking you to maximize something, so they want to know the largest possible area. That goes into your maximization equation. So we know that area of a rectangle is length times width. So I'm going to say I want to maximize that area. So area is length times width. But I'm going to use x and y instead of length and width. And we're going to use this for x, the horizontal distance, and we'll use the vertical distance as y. I like to use x because that reminds us of the x-axis, and y going up and down reminds us of the y-axis. And we're going to need a little bit of a helper equation, and that comes from the beginning part. The farmer wants to construct a rectangular pig pen using 500 feet of fencing. So that is going to help us. Fencing, you should be thinking perimeter. Fencing is all of what would be needed to fence in going all the way around. So technically there are 2 y's, this y here that we're going to fence, this y and this x. So all of this added together should equal 500. So it's x plus 2y must equal 500. That is my helper equation. And then this is the equation we need to maximize. However, this equation must only contain one variable. That is why we need our helper equation. So what I'm going to do with this helper equation is I'm going to solve it for either x or y. It looks like solving it for x is going to be easier. All I'm going to do is subtract 2y. And I don't have to divide by anything, so I'll solve for x. So x is equal to 500 minus 2y. And what I'm going to do with that is help and put it into my max equation for x. So we have area is equal to x, which is 500 minus 2y, then times this y. And I'm going to simplify it a little bit more by distributing the y. So 500y minus 2y squared. So this is my equation that I need to maximize. So in order to maximize an equation, we need to use the derivatives. So we're going to I'll call it a prime to find our derivative. So 500 times y is nothing other than 500. And the derivative of negative 2y squared is just negative 4y. And whenever we want to find a max or a min value, remember that we have to take the first derivative and set it equal to 0. And solve. So I'm going to add 4y to both sides. So we get 4y equals 500. And divide both sides by 4. And we get 125. So the question is really, how do I know that this is a maximum value or a minimum value? Well, because we only got one value, we can assume that it's the maximum, but I'd like to just test it out anyway by doing a number line with my a prime, my first derivative. So I'm going to put the y value of 125 here, and I'm going to test a value that is smaller, and I'm going to test a value that is bigger. So I'm going to use my A prime equation, which is here. So if I'm choosing a number that's smaller than 125, I don't know, say 0. So 500 minus 4 times 0. So 500 times minus 0 is 500. That's positive. So we can go ahead and put pluses here. And let's pick a number bigger than 125. I don't know, say 200. So if you plug in 200, 500 minus 4 times 200, that gives you a negative value. So when we draw our picture, we're going up and then down. So therefore, this obviously has to be our maximum. Now this is just me proving it to you that it's a maximum, but if you just get one value, you don't really have to do this. Okay, so if this is our maximum y value, we just need to find the maximum x value. So we're going to go back to our helper equation and plug in. So x is equal to 500 minus 2 times 125. So go ahead, type that into the calculator, and then hit resume when you're ready for the answer. So x should be equal to 250. So when they ask you what are the dimensions are x and y. So 250 feet by 125 feet would be the appropriate answer. You could say 125 first by 250. They usually do smaller by larger, but that's fine. And that's it. Those are my dimensions. All right, let's try a different type of equation. Okay, so question number 2 says, a rancher wants to construct 2 identical rectangular corrals using 400 feet of fencing. The rancher decides to build them adjacent to one another so they share fencing on one side. What dimension should the rancher use to construct each corral so together they will enclose the largest possible area? All right, so same concept. We need a picture. We need a helper equation, and we need a maximization equation. So the picture is saying that we have a rancher that wants to create 2 rectangular corrals that are adjacent to each other. So here's my picture. They're rectangular and they share fencing on one side. Those are my 2 corrals. Then they tell us that the rancher wants to use 400 feet of fencing to do this. That is my helper equation. So we need to figure out what the dimensions are. So I'm going to make this, you can make this entire thing x if you want, or you can make this smaller piece x. The reason why I'm going to make this smaller piece x is because they want to know what dimension should the rancher use to construct each corral. Each one of these are my corrals. So I'm going to make this x, and then I'm going to make the y's be the verticals. So technically, I have 1, 2, 3, 4 x's and 1, 2, 3 y's. So my helper equation is 4x plus 3y equals 400. And they want to know what are the dimensions that the rancher should use to construct each corral so that they enclose the largest possible area. That is your max. So since this is each corral, the dimensions of this corral would just be x times y. So that would be my area. So area is x times y. So just like we did before, we need to maximize this equation by using derivatives, but we can't do it with 2 variables. So we need to go to the helper equation and solve for one of the variables. It really doesn't matter which one you solve for. I'll solve for x. So I'll subtract 3y. So 4x equals negative 3y plus 400. And divide every piece by 4. So we get x equals negative 3/4 y plus 100. And now this x has to go into that x because it's the helper equation. So area equals negative 3/4 y plus 100 times y. And then let's distribute a little bit in. So negative 3/4 y squared plus 100y. So this is my maximum equation that I'm going to need to take the derivative of. So we'll call the derivative a prime, and we'll take our derivative. So 3/4 times 2 is negative 3/2 y plus 100. And remember, to find the maximization, we need to set our derivative equal to 0. So a prime is now 0. Negative 3/2 y plus 100. And solve for y. So I'll subtract 100 on both sides. Negative 3/2 y. And I'll multiply both sides by the reciprocal of 2 over negative 3. So these cancel, and we get 200 over 3. Okay, so if that's my y, then we're going to need to plug it in to find my x. So I'm going to go back to this equation. So x is equal to negative 3/4. The y is 200 over 3, and then plus 100. So take a minute, pause the video, type that into the calculator, and then hit resume when you're ready for the answer. And you should get 50. So my final answer for the dimensions, right? Remember, dimensions are x's and y's. So 50 feet by 200 over 3 feet would be the final answer. All right, that's it for today. If you have any questions, please let us know.